In today's video, we're enhancing our ServiceStack-based CoffeeShop application by integrating it with Microsoft's TypeChat. Building upon the solid foundation we've already laid with our GPT-powered CoffeeShop project, we'll guide you through the steps for how you can incorporate some of the same patterns so you can build even more robust AI-driven applications. In this CoffeeShop application, TypeChat acts as a strict validator designed to meticulously check the JSON output from AI services like OpenAI's large language models. This validation is not just a nice to have, it's essential for ensuring that your application functions as expected, especially with dealing with these probabilistic systems like AI-driven features. Incorporating TypeChat into your ServiceStack app further fortifies your type safety, which is already a strong suit of ServiceStack due to the way it defines its services using C# DTOs. This heightened level of type verification enhances your app's stability and reliability, enabling you to get the most out of these AI services. By the end of this video, you'll have a blueprint for building a complete voice ordering system for a coffee shop, serving as an actionable guide for your own similar projects. Central to this tutorial is the use of the ServiceStack.AI library. This resource acts as a flexible layer of abstraction, allowing you to seamlessly incorporate various AI and GPT services without committing to a specific provider. This versatility ensures that your application is not only robust, but also future-proof against the ever-changing landscape of the AI technology we have today. Okay, so armed with the implementations and abstractions in the ServiceStack.AI library, it's time to delve into one of the most crucial aspects of this voice ordering system, and that is our speech-to-text integration. There are a host of services out there that can fulfill these requirements, and each brings its own set of features to the table. If you've decided to kick things off with Google Cloud speech-to-text, the ServiceStack.GoogleCloud library already has an implementation of the iSpeech-to-text interface that utilizes the Google Cloud Speech v2 API. This interface is a simple one with just two methods of init async and transcribe async, effectively encapsulating the essential functions that we'll need from any transcription service. Including Google Cloud speech-to-text, the CoffeeShop application is already configured to work with 3 different speech-to-text providers. By default, it actually employs the OpenAI's Whisper API, which you can specify in the app settings.json. Each available provider is neatly set up in the configure.speech.cs file, making it incredibly easy to switch between them based on your individual needs. And if you want to use the Whisper API or a local Whisper model, you can do so with the ServiceStack.AI library, which already provides implementations. Now, it's important to note that if you opt for the Google Cloud speech-to-text implementation, you must have your PC configured with Google Cloud credentials and ensure that the speech-to-text API is enabled for your Google Cloud project. The Google Cloud implementation also requires the use of the init async method from our interface to seed it with some known phrases for better accuracy. On the other hand, for those that do prefer OpenAI's Whisper model, you can also use the Whisper local speech-to-text option. All you need to do is install OpenAI's Whisper model locally, which can be either on your system's path or specified in the Whisper path option in the app settings.json file. These providers are remarkably straightforward with no need for initialization. When the user records their voice for the speech-to-text interface, we need to store those recordings somewhere before we pass them to our speech-to-text models. Storing audio files can be done either locally or in a cloud storage solution like Google Cloud Storage. Your choice here will depend on your application's need, though if you are using Google Cloud's transcription, it is beneficial to use their Google Cloud Storage as well for lower latency. Once you've decided on your audio storage strategy, whether it be local or cloud-based, you'll find that ServiceStack's managed file upload feature fits nicely into this equation. It supports a variety of storage solutions to cater to different needs, and yes, it now supports Google Cloud Storage as well. And because it uses ServiceStack's virtual files interface, it means we have a variety of choice, including local file system, S3, R2, Azure, Gist, and others. This feature is incredibly useful because it enables seamless integration of file uploads into your HTTP APIs. It's particularly handy in scenarios like autoquery CRUD APIs where you might want to save the file path in the database without embedding the actual file, thus conserving valuable database storage. So we can have a single ServiceStack service to handle the upload and transcription, and our client simply appends the file upload to the form data in our view service client before calling the transcription service. This means you can include any details like a normal web service API call and append the file knowing that by the time it reaches your service, it's stored in your virtual file system. With the ServiceStack.AI library integrated using its interfaces, setting up your own voice transcription API becomes straightforward. This API leverages the iText-to-speech.transcribe async method for transcription and stores the result in the database. On the client side, we have an audiorecorder.mjs JavaScript module which has a view component which offers a straightforward way of handling audio capture. You can then use the ServiceStack client library to upload the file as we discussed by just appending the audio blob using formData.append. Our transcription service will then respond with the text from our audio, and this takes us to the next phase of our project where we will employ TypeChat to convert the transcribed voice message for customers into an actionable order instruction that our application can readily process. First off, let's consider the iTypeChat provider interface, which is also a part of our ServiceStack.AI library. And in this project, we have two providers, the Node TypeChat provider, which goes through a node process and interacts with the native TypeChat library, as well as one based on semantic kernel. It has its own prompt.ss file which uses SharpScript to construct a prompt very similar to that of TypeChat. So both still use a schema, a prompt, and a user message, and that leads us to the TypeChat request class. This class is used by the iTypeChat provider interface on the translate message async method. This request class has everything we need to invoke TypeChat natively through Node. When used with the default Node TypeChat provider, we also have a script path, and this will be by default a typechat.mjs file. This JavaScript module is responsible for invoking TypeChat natively, so this will invoke either one of two types of translators in the TypeChat library. That is, either a JSON translator, which is used in this CoffeeShop example, or a program translator, which we will look at in a separate video. So when this JavaScript module calls TypeChat's translator.translate method, it's actually calling the OpenAI API services for us, getting that response and passing it back to our .NET process. This means by the time we have a string back in our .NET process, it's been validated against the schema we have specified, so we know that it is actually valid JSON. If we look in the schema.ss file, we will see that there is a cart declared at the very top of our schema. This is the interface or type that our program will be validated against for a JSON program. Our typechat.mjs is picking out the first declared type or interface to do this. So once the translate message async method has finished, we will either get a response status containing the error or a valid JSON string in the result property, which in this example will be an instance of a cart. So if we don't have an error, we can easily just deserialize that result string into the type that we expect, knowing that TypeChat has validated the response for us. So when it comes to transforming natural language into structured data, both semantic kernel in C# and TypeChat in TypeScript offer distinct advantages. Semantic kernel offers fine-grained control for custom validation and bespoke application logic, whereas TypeChat simplifies your workflow with automated retries and schema validation errors. If you need that additional customization where you need to control that prompt, this is where you'll also use the iPrompt provider interface. In our CoffeeShop example, we have the CoffeeShop prompt provider. This pulls information from our database and uses TypeScript to construct both our prompt and our schema. While the schema is used by both the semantic kernel and the node TypeChat providers, the prompt is actually only used by the semantic kernel implementation. This is because TypeChat constructs the prompt for us. If we look in our Appos project called CoffeeShop under the GPT directory and then CoffeeShop, we will see two .ss files for TypeScript, the prompt.ss and the schema.ss. The prompt.ss is for the semantic kernel implementation to essentially recreate what TypeChat is doing with their prompt. So this means that the iPrompt provider and the iTypeChat provider are completely separated, so you can mix and match as you need. And with the CoffeeShop example application, we can see the different ways we can combine these technologies together thanks to those simple interfaces in the ServiceStack.AI library. And to round off this CoffeeShop example application, we have a Vue.js UI that pulls all these services together. And this will let us order our favorite coffee or bakery good, which is configured and stored in our database like we saw in the previous video. This makes it easy to manage different products, options, or categories. And we have a live hosted demo if you want to try it out yourself at coffeeshop.netcore.io, for which I'll leave a link in the description. Which leaves us with trying out the running application itself by ordering an iced coffee and a bagel, watching it transcribe my voice, extract the items I want, and present me with the cart to confirm my order. If you want more details about the ideas presented in this video, check out the ServiceStack.net blog and our second blog in this series. It has all the code you'll need and links to all the examples, for which I'll also include in the description of this video. By using flexible interfaces like those in the ServiceStack.AI library, you can create your next AI-driven application with a variety of different services without locking your application to any specific vendor. And with things changing as quick as they are, that can be a crucial implementation detail for your next startup or application idea. Well, that's it for this video. If you have any suggestions or feedback, do let us know in the comments below or join us in our community Discord or GitHub discussions. ServiceStack is free for individuals, so anyone is welcome. And as always, thanks for watching.